This is going to be interesting. Yeah, this is going to be interesting. I'm sorry for the people I cannot see. I'm too small. So, yes, hi. My name is Corinne. I'm here to present, yes, configuring is good, but have you ever tried justifying? So, quite a subversive title for a configuration workshop, but here we go. First of all, thank you, David, for actually introducing exactly like a use case for what I'm going to say. So, first of all, my team, so I'm Corinne, I'm from NTS in Montreal, Canada. I've been working under Sébastien Mosser, who's been at McMaster University and works with two interns that we've collaborated with, Aaron and Disha. And we've also benefited from the expertise and ancient knowledge of Jean-Michel and Mireille, who are working in France. So, as the title says, yes, configuration is nice, but it's insufficient. What we're trying to say with this is that configuration without justification creates problems, and a lot of problems, and sometimes even death. So a few, and actually that's true. So actually a few examples, like in 2021, we've all seen what happened with Facebook, or all of Meta actually, when it suffered a 6-hour outage, and that was because of a DNS issue. Another example, in France, Orange, the biggest telecommunication provider in France, suffered an 8-hour outage and disrupted its 112 services, which is equivalent to 911 in America, and because it updated its call servers. And then more recently in Canada, where I'm from, Rogers, one of our biggest telecommunication provider, also deleted one filtering rule in its systems, and it actually flooded its own systems. So then it suffered a 15 hours outage, disrupting also 911. And I think the Orange one actually might have been implicated in the death to 6 to 10 people because the emergency services were not reachable. So all these incidents were actually caused by configuration errors, and mostly they were all avoidable, and that's how can we do better, actually. So we need to understand the why behind configuration. This is critical to what we're doing. We understand that deleting a filtering rule doesn't seem like much, but if it ends up causing deaths, then there's something to do here. We need to make the justification explicit to better understand why things are configured the way they are. Those incidents would not have happened if engineers had understood more deeply the legacy system they were working with. Why is the configuration this way, and why can I not change it right now? So when I'm talking about configuration, of course I'm talking at large, but specifically for this case, I'm going to be talking about YAML mostly because my field of expertise right now is pipelines, so I'm staying in my lane. So this is a Docker Compose first version of a CI/CD pipeline. This is their first version in 2020, actually the 3rd of April 2020, for the project Docker Compose. So that was over 3 years and 6 months ago, and actually more than 80 commits ago. So like maybe now someone at Docker could explain to you what's happening here and why they made those changes, but certainly in 5 to 10 years, nobody will be able to tell you exactly why they made those decisions. And that is a problem. So how do we go about this? How do we justify and make sure that everybody knows why we're doing the choices that we're making? So how do we do that? We could reverse engineer commits messages. That's exactly what a colleague of ours is doing, Bentley Oaks at Polytechnique Montréal. But that, of course, I've been doing that for the most part of the 3 last years, and it's a hassle, it's long, it's difficult, it's super error prone, so let us not do that. The only reason why Bentley Oaks research works is because it's working with Linux commit messages, and Linux commit messages are extremely standardized. What else? We could maintain documentation in parallel to source code and configuration. But again, that doubles the work, and there's a high risk of mismatch. And if we're really honest, like eventually engineers are just going to stop doing it and go for the code. So let us not do that too. So what can we do? Well, we propose to focus on justification and then eventually add implementation details to it, and then eventually we could automate configuration generation and validation. So, how do we go about this? We want the how to support the why and not the other way around. We want to be able to not configure first and then explain why we did it. We want to understand why we're doing things and then go about how we're doing it. So justifying is, those are my papers, anyone who wants to see them, but I've been working with justification diagrams for a couple of years now. So they were introduced by Thomas Polasek in 2018. They're designed for software accreditation and validation, actually. We reworked those a little bit to go with DevOps pipelines as of 2021. And I've created a visualization tool available on GitHub. So generally, how they work is fairly straightforward. At the top, you have your conclusion. What are we trying to do? What's the end goal? And then you have, in green, you have strategy. So how do we go about justifying this? How can we prove the conclusion that's going to be on top? So under there, you can have sub-conclusions, which are the result of other strategies and so forth, until you get to the leaves of that kind of tree, which are supports. So what are the physical, tangible proofs that support your conclusions? Sadly, those are still documentation. Those are still just more paper that you can add to your project and that nobody will eventually read. So we're right back to what we were saying into, and yeah, this sucks. We don't want this. So then Jean-Michel Bruel had a really great idea. He said, what if justification were operational? And we all took a moment and said, what? What are we saying? So we're going back to what we're saying here in 3. Focus on justification, add implementation details, and then automate configuration generation and validation. How do we do this? So when we went to do justification diagram for another research, we made a simple DSL, which was very heavily based on Plant2ML because we hoped it would be eventually part of Plant2ML. That is long gone since, but that's what it was, so it's still there. So we simply had it was fairly straightforward again, so we had the support, the strategies, and they all had like aliases if we wanted, and then labels if we wanted. Simple links. Anybody who's done UML here sees the resemblance. It's exactly the same. And yeah, that's the language that we implement to do the justification diagram that I showed you just earlier. So now, if we wanted to make it operational, then what we could do would be to make it so that we, instead of having supports, so the leaves, the tangible proof that you could have at the bottom of the tree, instead of that, what we could do is have evidences. So what are evidences? Evidences would be, again, anything that you could produce that would be tangible proof of what you're doing. For this language, we just went a little bit more with semantics. So instead of having those arrows that we just use in UML, we moved away from that and just went with verbs. So evidence is, it's labeled. This support actually supports this strategy and so forth. Yeah, so this is nice. But what if we could push it a little bit further? What if we could add patterns to those? What if we could create patterns that could be reusable and eventually composable inside those diagrams? What if we could define a pattern as any support or evidence that would be used to support another strategy and then another conclusion and so forth? Well, in that case, we could have patterns which are an abstraction of what we were going to do, and then obviously we'd have implementations. So we'd have an agnostic pattern that would be able to just say, I need any kind of evidence to support this subconclusion, this strategy, and then go so on. And then we could add this implementation to it saying, okay, for this case exactly, I want to use, I don't know, YAML, I want to use XML, I want to use anything, actually a Jenkins file, who cares? I want to use this language to implement this justification. This is how I'm going to do it. But see, we are severing the link in between why and how. We're making the why extremely explicit so that we understand why we're doing things, so that any engineer would come up and want to update that configuration, so the how we're doing it, and would have to go through the why, so would have to go through the justification to make sure we are understanding why we're doing everything. So using this, it would be super easy. So I went way too fast, but in any case, so what's next? So like I said, justification diagrams were originally proposed to be used for accreditation in railways and avionic industries. So what we're trying to do here was to prove that to get this accreditation, I need the software to do exactly those steps. And this is a way to prove that those steps are implemented in the code at exactly those places. We will use those for DevOps pipelines to say that I want this pipeline to be able to meet those goals. So here is each step that goes towards that goal. But actually, this could be applied to any configuration use case. Anywhere you can have a configuration and a why you're doing things, and then how you're doing things would be probably implemented. So the tool that we're using right now, it's called JPipe. It's in development. We're working with students from McMaster University. It's an open source project. Anybody can go and see it on GitHub. Please come and try your hand at it if you want to just try stuff. And I want to make a shout out to Nirmal Chaudhary because he's been maintaining thanklessly the repo for a year now, I think. So thank you so much. And yeah, we're really interesting to know what you guys think about this.
Thanks a lot.